Dennis, you and I both love getting out into the environs, as they say, to look at environmental practice, and that's exactly what we did. Now, one of the early issues to resolve is to work out where the natural water courses are coming off the landscape, and here they're coming through right down here where this water's pooling. And that's exactly, of course, Dennis, where we want to put the drainage system. So we need to divert nature so engineering can take over for a while.
Yep, that's right, Peter. In fact, this is quite a good example of a creek diversion. What we can see here is that they have diverted nature, as you put it, or they've diverted the creek around the site where we want to place the culvert, because we want to put the culvert where the creek was in the first place. And they've done a good job of it here, because as you can see, they've lined the whole channel with geotextile, and this is good environmental practice. What we have now is a situation where we're going to have clean water collected upstream of the culvert site, diverted through the culvert site in a geotextile lined channel, and it won't collect any sediment in the process of going from one side to the other. So it's good engineering practice, and it's also good environmental practice.
And once the transverse drainage is established and in and working, does this then become null and void?
Yeah, once the pipe culvert is installed and we can get the embankment constructed, then the water will be diverted back through the culvert and the diversion will be removed.
So this is where nature and the RTA come together as one. Now, I'd imagine by their nature, Dennis, that drainage lines are often located in existing creek beds. Now, what little knowledge I have about soil chemistry, do we ever have to worry about acid sulphate soils?
Well, acid sulphate soils are one of the things we could encounter. Others are what we call soft soils or even saturated soils, but yes, acid sulphate soils can be a problem.
Okay, so the very name suggests a problem, acid and sulphate. Are we talking sulphuric acids?
We are. Acid sulphate soils are the name given to the naturally occurring soils or sediments containing iron sulphides, or the acidic products of the oxidation of those sulphides.
Right, yeah. Not for me, Dennis, but just for people watching, refresh us on the basic chemistry.
Well, Peter, when sulphides are exposed to air, oxidation takes place, and sulphuric acid is ultimately produced when the soil's capacity to neutralise the acidity is exceeded.
Not only an engineer, but a chemist as well. But the thing is here, it's the exposure to air which is the critical thing.
Yeah, as long as the sulphides soils remain under the water table, oxidation can't take place and the soils remain quite harmless and can remain there indefinitely.
But once oxidation occurs, bingo, that's when you get sulphuric acid. Now, managing acid sulphate soils is out of the scope of this episode, but good information can be found in the RTA guidelines managing acid sulphate soils.